Okay, Julia, Gulia. I erased the other one because I didn't like it. I was afraid it would confuse you a little bit. So I sent your mom the video on alpha, beta, and gamma decay. Just the main thing with those that you have to know for the standard. I'm not sure what your teacher's having you remember, but alpha decay, you need to know, is basically a helium atom that's being ejected. Beta decay is an electron that's being ejected at high speeds. And gamma rays are high amounts of radiation that are just basically like light waves. The one that can go through the most objects is gamma rays, and the least is alpha. Alpha and beta can be damaging, though, if you breathe them in. They can be really damaging. But like gamma rays are super Mac Daddy bad, okay? So the video should help with that. I'm going to show you what half-life is. And so half-life, and while I'm doing this, I'm plugging in my computer because it just showed me that it is about to run out. But half-life is the time that it takes for half a substance to decay. Okay, and I'm going to draw a little picture for you really quickly. And I apologize. I'll pause. Hold on just a second. Okay, sorry about that. So it's the time that it takes for half of the sample to decay. Okay, so if I come on here, let me delete this from before. Okay, so half-life is the time it takes for half a sample to decay. Okay, so if I have a sample, and let's say it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and let's say that the half-life is, let's say that, well, the half-life in general, if we say that we have one half-life, okay, so after the first half-life, you would have half of it left, which is 6. So 1, 2, 3, 4, 5, 6, and you have 6 left over after the first half-life. Okay, this is after the first half-life. After the second half-life, you would have half of the remaining sample. So that would give you 3. Okay, and so you would have 3 left. So that's after the second half-life. After the third half-life, you would have, so this gives you would have 6 after this one, 3 after that one, and then you would have 1 and a half of 1. I'm going to ixnay that one over there. So you'd have 1.5 left, okay? So you're never going to run out. You just keep taking half of it. And so that's basically the idea of half a sample, okay? Or half-life. Okay, so let's look at a specific example. And I pulled this up from the internet. It says an isotope of cesium-137, which is just its name, so don't even worry about what that's called, has a half-life of 30 years. Okay, if you have 1 gram of this stuff, okay, and it breaks down for 90 years, how much left? Okay, all right, so we know that the half-life is 30 years. That means that the time it takes for this sample to decay of cesium-137 is 30 years. Half of it to decay is 30 years. Okay, so if you had 1 gram for 90 years, how much is left? Well, first of all, we need to see how many half-lives are left, okay, or how many half-lives have passed. So we know that it's been going for 90 years, and we know that 30 years is your half-life. So we're going to divide this by 30 years, which gives us 3 half-lives, okay? So we have 3 half-lives. So the way I do this is I draw this out and I put original for the first one. 1, 2, 3. Okay, so the original is 1 gram. Okay, after one half-life, you have half of that left. So half of 1 is 1/2 gram, or 0.5. Okay, after 2 half-lives, you have 1/4 of it, because 1/2 times 1/2 equals 1/4. And if you look at that as a decimal, it's 0.25 or 0.25. Sorry. Okay. After 3 half-lives, you would have 1/8 of it left. If you divide 1 divided by 8, you get 0.125. So you would have 0.125 grams of that sample that remained. Okay, so after 90 years. Okay. All right, so let's look at another one. Actinium 226, okay, that's the name of the element, has a half-life of 29 hours. Okay, if you had 100 milligrams of actinium, if 100 milligrams of actinium 226 disintegrates over a period of 58 hours, so you have 100 milligrams to start off with, and it's been going for 58 hours. Okay, then how much left? Okay, all right, so again, it's been going for 58 hours. I know that the half-life is 29. So I have to take 58 divided by 29, which gives you 2 half-lives. Okay, so we're going to do our little thing again. Do 0, or the original. Okay, 1, 2. So my original sample is 100 milligrams. Okay, and I know that half of that, the first half-life would be half of that, which is 50 milligrams. And then the second half-life would be 25 milligrams that are left. Okay, so that would be how many you have left. All right? Okay, one more, and then I'm going to show you one other thing. Okay, so sodium 25, which I'm going to write out like this, was to be used in an experiment, but it took 3 minutes to get to the lab. Okay, so it took you to get 3 minutes to get it from where it was at to the lab. Okay, if you had 5 milligrams of sodium that was removed, so this is your original sample, from the reactor, how many milligrams of sodium 25 were placed in the reaction vessel 3 minutes later if the half-life of sodium is equal to 60 seconds. Okay? So, oops. Let me turn this down. Just came up. Okay. So, your half-life is 60 seconds. I would change this over to a minute, okay? So, because you need this time to be the same as this time measurement, okay? So, 60 seconds is equal to 1 minute, okay? And then I take my 3 minutes, divide by 1 minute, and I get that I've had 3 half-lives, okay? So, we set this up the same way. 0, or your original, 1, 2, 3. Okay, so your original sample is 5 milligrams. Half of 5 gives you 2.5. Half of 2.5 gives you 1.25. Am I right? I'm second guessing myself this late at night. Yep. And then if you divide 1.25 divided by 2, then you get 0.625 milligrams that are left over. Okay, and so I have to do these little charts like this because it just is more visual for me. If you figure out how many half-lives you have, then you just plug in your information and divide by 2 every single time. Now, sometimes they'll ask you something like, say, you have 4 half-lives. What fraction of the sample is left? Okay, and so you do this the same way. I do the original, 1, 2, 3, 4. So the original would be like 1. Okay, the first half-life would be half of 1, which is 1/2. Second half-life is half of a half. So 1/2 times 1/2 is 1/4. Half of 1/4 is 1/8. And then half of 1/8 is 1/16. So your fraction that you'd have left after 4 half-lives is 1/16. Now, sometimes they want to know percentages. So if I want to know percentage, you just take the numerator divided by the denominator. So 1 divided by 16 is 0.0625, and you multiply that times 100, and that gives you 6.25%. Okay, 1 divided by 2 would be 50%, so on and so forth. I know you know how to do that stuff, but just kind of to remind you. If you have any other questions, ask Mom to give me a call. Otherwise, or if you want me to go over any of your problems that you have that you don't understand, just send it to me. You can text me yourself if you want to. My number is 770-862-9664. So whatever you need. Talk to you later, Julia.